Welcome to Engineers Mindset. Alright, so in today's class, we'll still consider dimension analysis. Considering the question on the board, it says if the frequency f of a stretched string depends upon the length L of the string, the tension T in the string, and the mass per unit length mu of the string. Question says establish a relationship for the frequency using the concept of dimension analysis. So let's state out what was given in the question. We have that if the frequency f, okay, is dependent, so directly um, depends upon the length L. So we simply have capital length L, okay, of on the length L of the string, the tension T, tension capital T, and the mass per unit length of the string. So they use mu to represent mass per unit length. So simply have this. So I said that if you're able to establish this relationship, the next thing to do is to raise this independent variable, because here frequency is depending on what these whole variables. It makes these whole variables an independent variable. So I said the next thing to do after establishing this relationship is to raise these unknown variables, is to raise these independent variables to what unknowns, unknown variables. Okay, so let's simply raise that to x. So it becomes L to the power of x, y, and t to the power of y, and mu to the power of z. So we simply have this. And then next I said is to remove the proportionality sign. And you know that whenever you remove proportionality sign, you introduce a constant. So this simply implies that the frequency itself is now equal to, taking off this proportionality sign, we introduce a constant k, L to the power of x, t to the power of y, and mu to the power of z. So we simply have this. So the third step is to simply what? Write the dimension of all the physical variables or physical quantities given to you here. So the first will have frequency. Okay, we have frequency f. Now, what is frequency? Okay, so first we have frequency. Okay, now the very best way to write the dimension of physical variables or physical quantities is actually from their units. If you're able to know the unit, it becomes easier, except for what difficult functions like this or quantities like this, like frequency. Now the unit of frequency is in hertz, but if you're able to know the formula for frequency, you can then write the dimension. But the very best way is to write from their units. Now we know that frequency is simply what? Velocity all over wavelength, which is lambda. So we can now find the dimension of velocity and dimension of wavelength. That gives us dimension of frequency. Now, what is dimension of velocity? The very best way, like I keep saying, to write the dimension of physical variables is from their units. The unit of velocity is simply what? Meters per seconds. That's the unit of velocity. And from our MLT system, remember we're using the MLT system of measurement to write our dimensions. M here stands for what? The mass. L stands for the length, which is dimension for what? When units are in meters. And T stands for what? Time, for when you have seconds. When the unit is in seconds, we simply use T to replace it. So unit of velocity is simply meters per seconds. So this actually implies that meters is a unit for dimension of what? L. Okay, length is what we use to dimension meters. So we simply, in place of meters, we simply have L all over seconds is a unit of time, and we simply use capital T to dimension time, so that becomes all over T. And of course, you know, you can simply write this to be L into 1 all over T. If you factorize L out, L times 1 still gives us L over T. And we know that by indices, 1 over T can be simply written as minus T to the power of 1. So this simply implies that the velocity v is actually what? Lt to the power of minus 1. So we can simply have this for the velocity. Okay, so if we're able to achieve this for the velocity, then what then is the unit of what? Wavelength. All right, so wavelength is actually measured in meters. The unit of wavelength, lambda, okay, is actually what? In meters. So it's easier to write the dimension of physical quantities from their units. It's very easy and better. The unit of wavelength is simply what? In meters. So this actually implies that Meters, of course, we use L to dimension meters. So it's simply what L. So which means the dimension for wavelength is actually what L. So if we know dimension for wavelength and we know dimension for velocity, it means we can find the dimension of what frequency, because from the formula frequency is simply velocity all over wavelength. So that means the dimension of frequency F is now equal to, we have velocity over wavelength. Dimension of velocity gave us LT to the power of minus 1. So we simply have LT to the power of minus 1 all over dimension of wavelength is simply L. So all over L. Of course, from here, L can cancel L. So this simply implies that the dimension of frequency is actually what? C to the power of minus 1. So we have this for the frequency. Okay, next is to write the dimension of the independent variables now. Of course, L still remains L because this is the length and unit of length is meters, and we'll use L to dimension meters. Okay, so L remains L. T is tension, not forgetting, and tension is a force. So for tension, let's dimension tension. Okay, for tension T, tension is a force, and of course, force actually has its value to be mass times acceleration due to gravity. That gives us the value for force, okay, for the tension. So we simply have now, recall that acceleration due to gravity itself can be measured in meter per second squared. So the unit is simply meters per second squared. So like I said, the very best way to write dimension of physical variables is actually from their units. It makes it easier. So if acceleration due to gravity is meter per second squared, and we know that L actually dimensions meter and T dimensions time. Recall that meters here is a unit of what? Length. So which means you simply use L to dimension it, and then second squared here is a unit of seconds is a unit of time. So we simply use T to dimension it. So that means we are simply going to have this to be equal to, in place of M as meters, we simply have L. It becomes L all over. Here we have second square, and the dimension of seconds is simply time. So it becomes T to the power of 2. You have this, and of course, this can also be written as simply L into 1 all over T to the power of 2 by simply factoring L out. And you can have here to be G is equal to L. And of course, by indices, 1 over T can be written as 1 over T squared can be written as T to the power of minus 2. So that becomes the dimension of acceleration due to gravity G. Okay, the next thing is to dimension mass. Of course, mass M is, from dimension analysis, we simply use capital M to dimension mass. So the dimension of mass is simply what? Capital M. So it simply means that the dimension of the tension T itself is now equal to what? We have that tension is actually a force and given as mass times gravity. Mass is capital M by dimension, and gravity is LT to the power of minus 2. So we simply have LT to the power of minus 2. So this becomes the dimension of what? Tension. Alright, so we've obtained dimension for the frequency, we've obtained dimension for L remains L, we've obtained dimension for the tension. Now let's obtain dimension for this. This function was given to us as simply mass per unit length from the question. So it was given as mass per unit length. So it simply means that the formula for this mu is actually given as mass per unit length. So we have to now obtain the dimension of that quantity. Let's try it now and see. Alright, so that quantity mu was simply given to us as mass, okay, all over length, and we know that dimension of mass is simply what? Capital M, all over dimension of length still remains capital L. So which means this can also be written as what? Mass, factoring mass out, M into 1 all over L. So if you simply factor mass out, M comes out, it still remains as 1 over L. Mass times 1 still gives us M all over L. And of course, by indices, this can be written as simply what? Mu equals M. So by indices, we can change 1 over L to simply be L to the power of minus 1. So this becomes the dimension of that quantity. So since we've known all the dimensions, let's bring out the basic equation now. Recall from the equation, the base equation gave us that F, which is the frequency, is actually equal to K, L to the power of X, t to the power of y, okay, t to the power of y, and then mu to the power of z. This was the equation, and k is a constant. The dimension of every constant is actually dimensionless, so constant is actually 1. Okay, there is no dimension for constants, so k is actually 1, it's dimensionless, so it's off. So if you have this now, we can now plug back the dimension of all the physical variables we've obtained into this equation and then find the values of what the unknown powers. If we do that, we are simply going to have, in place of f, we simply obtained, okay, for f we obtained t to the power of minus 1. So in place of f, we simply have t to the power of minus 1, and this is equal to, in place of l still remains l since it's length. So we'll have l to the power of x. Also, in place of t gave us ml t to the power of minus 2, but not forgetting that t is raised to the power of y here, so raise it to the power of y. And in place of mu, okay, mu simply give us ml to the power of minus 1, so we'll have ml to the power of minus 1 to the power of z, not forgetting, to the power of z. So you have this. So this is actually, remember, k is dimensionless is 1. So even if you add the 1 here, it still remains the whole of this. So that is off. So if we now expand this bracket, we are going to have that c to the power of minus 1 is equal to, this is l to the power of x. And if we expand these powers with this bracket, if we expand the powers of all these variables with what, the power outside the bracket, we are simply going to have times m to the power of y, okay, times L here, also to the power of y, and then times minus 2 here to the power of y. So we simply have t to the power of minus 2y. So you have this, okay, times here, this m to the power of what, z. Z multiplies m here. You simply have m here to the power of z, okay, and then you have l to the power of minus 1 here multiplying z. That gives you l to the power of minus 1 times z gives us minus z. So you have this. So this becomes um, the basic equation. Now all we need to do is to arrange these equations in terms of MLT system of measurements. So they all have to be in terms of MLT. Not forgetting, here I have t to the power of minus 1, and of course I can rewrite that equation. T to the power of minus 1 can also be changed. This actually means m to the power of 0, L to the power of 0, and then t to the power of minus 1. Because all I need to do at this point is to rearrange these equations to be in terms of MLT, both on the left hand side and both on the right hand side of the equation. That's all I need to do. Now recognize that any variable to the power of 0 is actually 1. So m to the power of 0 is 1, L to the power of 0 is also 1. So at the end of the day, I simply have here 1 times 1 times t to the power of minus 1, which will still give me what? T to the power of minus 1, which is same thing as what I have here. So it means now that this equation t to the power of minus 1 can simply be written as what? M to the power of 0, L to the power of 0, and t to the power of minus 1. Okay, so let's try it now and see. Alright, so just to continue from the previous equation, so I explained that t to the power of minus 1 can also be written as m to the power of 0, L to the power of 0, and t to the power of minus 1. It still gives us the same thing. Okay, I already explained this the other side. Now this is now equal to, so like I said, all we need to do is to simply arrange the whole equation to be in terms of MLT. So which means we have to maintain the same energy on the right hand side of the equation. So we bring all the m's together, all the l's together, and all the t's together, just to arrange them in form of MLT. And if we do that, we'll have here I have m to the power of y, okay, times I have here m to the power of z, bring them together, m to the power of z. So that's all the m we have. Next is l. I have here l to the power of x, okay, times I have here l to the power of y, bring them together, times I have here l to the power of minus z. So you simply bring them together. And finally, t, I only have here t to the power of minus 2. y. So it has now been arranged in terms of MLT, but we still need what further work to be done. All right, so we have here m to the power of 0, l to the power of 0, t to the power of minus 1 equals. Okay, so from the law of indices, once two variables multiply each other having the same base, what do? Simply pick one of the variables and add their powers together. I have m to the power of y here, multiplying m to the power of z. They have the same base, m and m. All you need to do is simply pick one of the base, m, and add their powers. So I'll simply have here y here plus z. This is according to the law of indices. Okay, times also the same thing happens here. I have L, I have L, I have L, three variables multiplying each other. All you need to do is simply pick one of the base since they have the same base, which is L, L, and L. Pick one of the base and add their powers. So I have this power here, x, plus I have this one here, y, but here I have minus z. So simply put down minus z, and then finally t to the power of minus 2y. So I have now successfully broken this equation down to what? MLT. So on the left hand side I have MLT, on the right hand side I also have MLT. That's the first condition. Now after satisfying this condition, the next thing to do is to simply apply the principle of dimensional homogeneity. Now, what is this principle saying? The principle is simply saying that the power of each of the variables on the left-hand side of the equation must be equal to the powers of each of the variables on the right-hand side of the equation. So for each of the physical variables that we have, like mass, the power of mass on this side of the equation must be equal to the power of mass on this side of the equation. That's the principle of dimensional homogeneity. So for the whole function to be homogeneous, their different powers must all be equal towards their respective powers on the other side of the equation. All right, so that simply means, let's start with m now. For m, okay, the power of m here is to the power of 0, so 0 is equal to the power of m on this other side of the equation, which is simply y plus z. So simply call this equation 1. Also for l, okay, according to the principle, the power of l on this side here is 0, must also be equal to the power of l on the other side of the equation. And here we simply have x plus y, which is here, minus z. Call this equation 2. And finally for t, the power of t on this side, remember, is minus 1. So we simply put down minus 1 equals to the power of t on this other side of the equation is simply minus 2y equals minus 2y. So we simply call this equation 3. So we have this. Now we see that from equation 3 it's easier for us to find the value of what? Y. So from 3, okay, we can simply make y subject simply by dividing both sides by what? Minus 2, which is the coefficient of y. So from 3, y is actually equal to, we have here, minus 1 divided by minus 2. So this simply implies that y itself is equal to, minus cancels minus, so I can be left with 1 all over 2 for the value of y. So this becomes the value of y. Now, if I know the value of y, it means I can find what? The value of z from equation 1. Because from equation 1, I actually have y plus z to be equal to 0. And now I've found the value of y as 1 over 2. So it means I can find the value of z. So simply what? Substitute y into what? Equation 1. Alright. So substitute into 1. And if we do this, we are simply going to have from equation 1, we have y plus z. So, okay, 0 equals y plus z. So we have 0 is equal to y is given as 1 over 2. So you simply have 1 all over 2 plus z. Okay, you have this equation to be this. That means in order for us to find the value of z, we have to simply send 1 over 2 over to the side of the equation. Not forgetting that 1 over 2 here is positive, and positive sign crosses an equal to sign will actually give us negative. So this actually implies that z itself is now equal to what? 1. Okay, it becomes 0 here minus 1 all over 2. So this implies that z is actually what? Minus 1 all over 2. That gives us the value for z. So if we obtain this value for z, we can quickly access equation 2 now. We know the value for y, we know the value for z, so which means we can find the value of x. So all we need to do now is simply what? Substitute z, okay, into equation 2. If we do that, from equation 2 we have here 0 is equal to x plus y, 0 equals x unknown plus, but we'll find the value of y, x plus y is actually 1 over 2. So you simply have plus 1 all over 2 minus, remember, x plus y minus z, and z itself is simply what? Minus 1 over 2. So minus 1 all over 2. That's what it becomes. So you have here 0 equals x plus 1 over 2. Minus times minus becomes plus. So you simply have plus 1 all over 2. Okay. This implies 0 equals x plus, of course, 1 over 2 plus 1 over 2 simply gives us 1. Okay. So to make a subject, simply send plus 1 over to this side of the equation. Positive sign crosses an equal to sign becomes negative. So I'll simply have a 0 minus 1 equals x. And this actually implies that x itself is equal to what? 0 minus 1 gives us minus 1. So we'll have this for the value of x. Now we've obtained x, we've obtained y, and we've obtained z. We can now plug back into the base equation. Remember the base equation. Recall that we said frequency is actually equal to what? K to the power of L, K times L to the power of X, T to the power of Y, and mu to the power of Z. We had this relationship earlier. So this actually implies that the frequency itself, F, is now equal to, remember, K is dimensionless, is 1, so it's always off, take it off. So you have L to the power of x, and x actually give us what? 1. Sorry, x give us minus 1, so it becomes L to the power of minus 1. Okay, t to the power of y, and y actually give us 1 over 2, so t to the power of 1 all over 2, and mu to the power of z, and z actually give us minus 1 over 2. Z actually give us minus 1 over 2. So you have minus 1 all over 2. So this becomes the equation. We can simply write this. Okay, so this equation can also be written. We can also rewrite this equation in terms of indices. F can be equal to, of course, L to the power of minus 1 is something as 1 all over L. Okay, we have here. Meanwhile, t to the power of minus 1 over 2 is something as simply the square root of t. Okay, not forgetting times, and mu to the power of minus 1 over 2 is simply 1 all over mu to the power of 1 all over 2. You can have this. Okay. Okay, so let's just bring back this equation here. So I simply said f equals L to the power of minus 1 over 2 can be written as L to the power of minus 1 can be written as 1 all over L, okay, times, and I said t to the power of 1 over 2 can be simply written as square root of t, okay, times, we have here mu to the power of minus 1 over 2 can be written as simply 1 all over mu to the power of 1 over 2, okay. So we can further rewrite this as simply what? Of course, 1 times root t can simply give us root t all over L times, same thing here, 1 all over, this is mu to the power of 1 over 2. Of course, converting 1 over 2 can be a square root to mu. You have this, okay? So this simply implies that the frequency itself is actually equal to root t times 1 gives us root t, okay, all over L times root mu, that gives us L root mu. So okay, so we simply have this. So this could be the accurate dimension of that given quantity. It can be simply written as this. So that's a relationship for frequency, the accurate relationship for frequency for that given question. All right, guys, I hope you find this video very interesting and helpful. Please, if you do, don't forget to leave your thoughts in the comment section. And of course, I will see you in the next video with more amazing questions on dimension analysis. Please, if you're new to the channel, do well to hit the subscribe button to keep getting updates when content such as this keeps dropping. Thanks and cheers.